Hi, it's Alan from Crashtest Security. In this video, I will tell you more about the differences between JavaScript, single-page, and traditional, multi-page web applications. Afterward, we will explain the specific difficulties of single-page applications from a security perspective. Finally, we will address the challenges of automating security tests for SPAs. So let's get started. Differences between single-page and multi-page applications. Specific security challenges for JavaScript applications. Challenges of automating security tests for SPAs. Identify security vulnerabilities in your web apps and APIs. Scan now for free. Share. According to the most recent Stack Overflow developer survey, JavaScript is the most popular programming language amongst professional developers, 697%. Most modern apps use this front-end technology to load content dynamically based on user behavior or other events. The core difference between single-page and multi-page applications is the app's behavior after a user interaction, i.e. clicking or scrolling. SPAs can only reload specific parts of the app. On the other hand, MPAs always transmit an entirely new page. The more technical explanation is MPAs. When multi-page applications react to user input or must show new content, they request a replacement hang page from the server. After receiving the information, the browser renders the new page, showing the user's reloaded page. SPAs, AJAX, asynchronous JavaScript and XML, permits JavaScript web applications to refresh a page section solely. When you interact with single-page applications, your browser posts AJAX requests to the server, rather than rendering a replacement page. The server will send you a part of the information. The SPA can then use that information to render specific elements of the page directly in your browser. Interesting facts. It is commonly said that MPAs make up the largest share of web applications, but I could not find a trustworthy source for this information. If you have one, please comment below. Most modern web pages are developed as SPAs, i.e. Google, Facebook, Amazon, etc. See Androjatis's blog for more examples and GIFs. The most common frameworks for SPAs are AngularJS, Reacts, and with some distance, Vue.js and Ember.js. JavaScript vulnerabilities in applications have some specific features that require specific security attention. One attack vector commonly mentioned is cross-site scripting attacks. There are multiple forms of XSS attacks, but they all exploit the possibility of injecting malicious scripts in client-server communications in various ways. Due to the separation of displaying and evaluating the content, SPAs can be more susceptible to XSS attacks. However, these can be prevented if you follow standard best practices guidelines. The bigger challenge, however, is the testing for security challenges in SPA applications. Traditional security audits followed the hang framework and commands to crawl the web application and identify potential attack vectors. All the crawler needed to do for each hang page was scan the first page, test the attack vectors, click on each link to get to the next page, and repeat until all pages were scanned. For JavaScript applications, this is not possible. In SPAs, content can be generated dynamically when the user reaches the end of a page, or certain features appear in pop-up or modal dialogues, only visible after a click. This presents challenges for the automatic testing of dynamic web applications. Attack vectors can now be found in the front-end, back-end, and communication of the two. These days, most security products require the user to manually create click sequences and specify specific value entries to discover attack vectors. This takes a lot of time and requires frequent changes to the security tool setup, i.e. when the software changes. One specific attack vector setup could easily take 5 to 15 minutes. Imagine implementing this for 20 attack vectors, and the next deployment, the app logic changes. Another 2 hours are to be invested. This work is especially challenging in an agile development cycle with automated CI/CD processes. If you want to learn more about other DevSecOps topics, integrations, or continuous security in general, visit our other content. Try Crashtest Security today to discover how it integrates into your development stack for efficient, automated vulnerability scanning. The trial is free. Also, subscribe to the Crashtest Security Channel to get more information about the most significant web security threats, their prevention, and how to use the Crashtest Security Suite. Thank you for watching, and see you in our next video.